Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is episode 55, CPU Fuzzing Part 5. We did a little CPU Fuzzing series and got most of the framework set up, but then realized that I really wanted some hardware to talk over serial. I'm sure all of you guys who are watching now know all of this already, but anyway. Once we got the hardware working, now it's time to actually do some fuzzing. Before I do that, I do want to go over some of the changes that I've made since the last stream. Because I've done some cool stuff. Particularly, let me show you guys what's going on here. If I turn on the Virtual Boy here, I can run this. And this is pretty sick when it works. There we go. All right, so what's happening here is it's sending a ROM, and this is so cool. I have this ROM that I wrote in C, and all it really does is clear the screen and then writes hello from C and then returns 42, right? And so what the framework here on the top level is doing is it tests this ROM. First, it sends it to the hardware, and then it sends it to the emulator, and then it reads the registers back and makes sure they match. And they actually totally do match, which is actually really, really cool. Just to use, the reason I'm doing fuzzing is because there are a few games that don't work properly in the emulator, and I'm fairly certain at this point that it's due to CPU bugs just because we explored the video hardware quite a bit, at least timing-wise. Yeah, I'll fix font size. Here we go. Something like that. But yeah, it's mainly that I want to fix hardware bugs, and I'm pretty sure it's the CPU's fault at this point. So I want to send blocks of code that will test the hardware and the emulator at the same time. And yeah. So what you're seeing here is exactly that already, where I built a test ROM and then it's sending it to both places and then executing it. And each time it like clicks here, it actually sends it to either the hardware or the emulator. So it'll say hardware dispatch or emulator dispatch here. Sometimes it gets stuck. That's actually pretty good timing. And I sort of know why, but I need to contact some other people and kind of figure that out. But I think I'm not going to worry about that today, because it's really easy to just restart the Virtual Boy and then it's fine. But anyway, if we look at the registers here, of course they match. And in particular, R10, which is the return value, is 2A, which is 42. That's exactly what my test ROM should return from main. So that's actually really, really rad. So I did do some work to get this to work. Particularly doing the emulator stuff was actually pretty easy. I just made a serial port here, which is emulated VB serial port. And that implements read and write, which is actually due to the way that I implemented the protocol stuff. That's actually all you need to send and receive these commands, because it just sends some serial data over these read and write ports. Sends and receives, of course. So the implementation is actually really cool because it basically just bootstraps the emulator. I don't actually need to bootstrap the screen on the emulator, but it just kind of helps to have that window up, even though I don't really pump the messages properly, so it's kind of crap, but totally works. And the funny thing here is that if we look at transfer byte and we look at the teensies version, so no, that's in here. If you look at the lowest level of the protocol, transfer byte will do things basically twiddling some bits and then delaying a certain amount of time, and then twiddling bits and then delaying. And the funny thing about that, when you hook that up to the emulator, is the emulator is in lockstep. Like since it's the emulator, we have full control over when it actually runs. And I've been very careful when writing the emulator so that we have a lot of control over the emulated time. So it's not just running on some thread and then we send crap to it. Like we want this to be fairly tight. So transfer byte here basically does exactly the same stuff with the clock bits. It actually doesn't have to do some of that just because of the way I wrote it. But instead of delaying, it actually steps the emulator the exact same amount of time. So in effect, it's the same kind of thing as like waiting for the hardware versus actually stepping the emulator. The two machines would have executed about the same amount of code. So it turns out to work really, really well. So the protocol here for this emulator-backed serial port is almost exactly the same as the stuff that the Teensy does when talking to the real hardware. It's just whenever the Teensy would delay, we step the emulator in the emulator port. So it's actually pretty cool. And then at the end, I just make sure to step this to add some emulated time between when we finish a command and then when the next one's allowed to move. And that just helps. I think this is a 1 millisecond delay, so that just helps keep things in sync. It sort of simulates the overhead of sending stuff to the Teensy via USB. It seems to work pretty well. I think where it gets stuck when talking to the hardware. And I mentioned this before that it seems like if we start sending a byte and the Virtual Boy wasn't actually ready and the Virtual Boy starts listening for a byte in the middle of us sending a byte, it seems that the transfer hardware on the Virtual Boy locks up, and then we can't reset it either from the Virtual Boy writing to the serial registers or from the Teensy just restarting the transfer. And I'm not entirely sure what that is. I've emailed a couple guys about that who are making Virtual Boy serial cables, and maybe they know. But again, I'm not going to worry about that too much today. Just if it gets stuck, just know that I'm aware of it, and I'm just not going to fix that right now because I really want to get to this fuzzing stuff, and I think that's kind of more valuable right now. By the way, hi to guys in the chat. Appreciate you guys being able to join me, even though we kind of started at a weird time. Just used 8 little bits. Try later, Mr. Liquid. Unjello. I think Pyro ESP. How's it going, guys? Zuckwar, what's up? Yeah. By the way, the reason why I'm starting at a different time now is because in Norway, you're required to take a certain amount of vacation every year. And I didn't take enough, so I actually have to take the rest of the year off, which is pretty nice. That's not too bad. But it just so happened that yesterday was my last day of work for the year. It was a half day. So I ended up coming in late instead, doing my work, and now I'm doing fine. But later today is our company Christmas party. By the way, thank you. I can't read that name, but thanks for the follow. Our office Christmas party is this evening, so I won't be able to stream late into the evening, but that'll be fine. Tomorrow, I don't have anything else to do, so I'll be working on this probably all day. But I might start late depending on how things go at the Christmas party tonight, so we'll see. Peteroya, G Superlin, how's it going? Oh, that's cool, Angelo. But yeah, so that's kind of what my plan is. I also have some stuff on Saturday, and I don't know how much I'll be streaming then too, because I need to prepare to actually go back to the US. But today and tomorrow, it looks like, are the prime days that we can work on this before I go. So I have thought a bit about the architecture for doing the fuzzing. So that little test ROM that I showed you just now, I took our little flat ROM thing and I extended it a bit. Just kind of want to show you guys how this works. It's kind of cool. This is the C ROM. It's super basic. Just basically copied the print stuff out of the test ROM. Just basic C code. The bootstrap stuff is a little different. I made this this entry section, this .entry section, because the thing is that when we send ROMs over the wire, they can't be in the same format that they normally are in. The main ROM format has a bunch of like vectors for the different hardware vectors like reset and exception handlers that are at certain addresses in memory, and that's mapped in the hardware to ROM, and so we can't really map those, and we don't really want to map those either. I'm thinking that our loader should actually try and reroute those to something in the ROM, but for now, it just doesn't make sense to have them. So the ROM format that I'm going for testing it's just a flat binary, and then the entry point is at the beginning of it, and it starts, I think, 1 kilobyte after the beginning of RAM, and that's so that the loader can have some space for its variables as well. So if we look at this ROM, there's an entry section, and all that does is just jump to what I call a stub, and then there's the text section which contains the stub, and all the stub really does is just set up to jump into C and then jumps into the C main. And the reason why we jump here and then don't do anything else is because from the loader's perspective, the loader will sort of call this code as a function. And so then we want to set up all of our stuff for C and then jump to C main so that when C returns, when the C main function returns, it will return to the function that the loader was calling from. As long as we don't mess up R31. But due to the way that C works, the C code and the compiled C code, that will actually be taken care of for us. So not really anything to worry about that. I do actually think I should probably change some of these registers to use R30 instead of some other registers, but it's fine. Because all of this will be deterministic in both the emulator and the ROM. And then the way I was able to put together that custom ROM format was actually really simple. Since we have control over the linker script, I just basically took the one that comes with VBDE and libgccvb, and I just moved around the sections so that the text section, first there's the entry section so that we know that the entry point is always the beginning of the binary, then all the different text sections. And then we have like all the data sections, and all of this just exists in RAM now. So originally the data section in the ROM, because it exists in ROM, but it needs to be modifiable, there's part of the bootstrapping code that will copy that into RAM. We don't actually have to do that. We can just point to it. So there's some things here that get a little simpler, but it's mostly just listing all the sections in order. And then the BSS stuff is at the very end. And then we don't actually put that in the binary. And same with this SRAM work area, which actually goes to a different part of memory, I think. But anyway, fairly basic stuff. And then the last thing is once we've laid out all the sections in this linker script, we get an ELF file, and then we OBJ copy that into a binary, and then we get the binary. So that particular C-ROM just looks like this. It's somewhat sizable only just because we have a lot of C, but you can see the different things here, like our entry sections up here, and it's going to jump into the code. The text sections, all this stuff. And at the end, we can see hello from C, the string here. So here's our data sections. And then this 0, 1, 2 through F is actually some of the print data as well. So pretty cool, actually. But I just wanted to share that. I want to use that for, because the thing is, I want to do this as regression testing. And since we have this hardware set up and it's so easy for us to just send a lot of realms, I really want to build a test suite out of this so that all the fuzzing stuff that we do, every time we like make a new kind of fuzzer, and I'll get to what I mean by that in a sec. I want to build that as a regression test so that if I whenever I make any changes, or if I want to do something in the future, say write a recompiler for the CPU, hint, hint, it would be awesome to have all of this fuzzing stuff as regression tests so that we can do exactly what we're doing here, where we're running on the hardware versus the emulator, and sort of separate that out into a bunch of different kinds of fuzzing. I'm also thinking that what I should do when I run it on the hardware versus the emulator, that I should also save out the values that the hardware got into sort of ref files, so that if we run the test suite without the hardware, it can test the emulator versus the reference files. And then we can actually run this on CI, which I already have set up for the project via Travis and AppFair. So that would actually be really rad. And then that's also why I set up this whole like assembler or C thing if we want to write more specific ROMs. Because I want to, for the fuzzing stuff, I want to just generate just a big blob of binary code. And I think that'll be okay. Which is also why I made the entry point just the beginning of the ROM. But then if we want to write some more targeted tests, we can do so in assembler or C, and also include those in the test suite. So I think I've got most of the stuff covered here, although I don't have like the framework for the test suite figured out yet. But I think it's, given the time that we have until I have to go to the US, it makes most sense to just start writing tests and kind of clean it up into a proper framework later, I think. So we're going to do the fuzzing test manually, and I'll get to that. But basically what I want to do is I want to make a generator for every kind of instruction. And the generator will take like a random number generator as input, and it'll basically be like an iterator. It won't use this same iterator trait that Rust comes with, because iterators return, their next function returns option of T rather than T, and I just want T, because these iterators will never finish. And there shouldn't be much point in using the iterators other than that, because I don't think we'll really need to like chain them or anything. But anyway, I want to do that. And then, so per instruction, there's about 50 of them. We're going to write like a generator that will generate random instructions for that instruction. And I think that's kind of a good way to do it, because we can basically do that based on the data sheet. And generating valid instructions is actually pretty easy, because a lot of them have like, oh, these 5 bits is the register, and these 5 bits is this, and these 5 bits are static, and it's not that many different combinations. Yeah, I'm not that concerned about that disease. It'll be pretty straightforward. If like if nothing else, what I can do is I can take the generators and just make an adapter that'll make an iterator out of a generator, and it's fine. But yes, that's exactly it, Try Later. I will totally be using a seeded RNG. That's going to be very important because we need, if we're going to be using this as a regression test, they need to be deterministic. So, and then the reason why I don't want to just use fully random stuff is because I don't have implemented a lot of the exception handlers for things like floating point exceptions. And I think it would actually be okay. But yeah, I don't want to do that until I know that I want to implement that stuff. I do want to do that eventually, but I want to do something more targeted at first. That's cool, Michael McMillan. No worries. So yeah, so I think I'm super happy with the setup that we built, and I'm super happy with how I think this will go. It'll be a bit tedious to write all these fuzzing things, but it should work out okay. And then, yeah, like I said, later, then I want to sort of clean this up. Because I was also thinking that while this can be used for CPU stuff, this is also general enough due to the fact that the Virtual Boy renders all of its graphics into frame buffers that then we can read. This is also general enough that one thing that I would like to do in the future is just write all of the video hardware registers and like all the window memory areas and all the OAM and like all the graphics data. Just fill that with random junk and then just have it render a couple frames and just see what comes out. I would love to do that as well because I know that I don't think there's been a lot of targeted testing around the video hardware when you give it completely bogus values. And so I would really like to use this framework to do that. Just because it would be such a natural thing to test. At the same time, we could also probably do some targeted tests using the C stuff that could test timing of the video drawing, which would be really nice. I don't know of any other emulator that emulates any of that yet, which, you know, we shouldn't have to, but it'd be really interesting to check that out. So, yeah. And then yeah, eventually I definitely want to send random sequences, but especially like I don't think I have instruction traps or anything implemented. We're definitely going to need those because we're going to definitely generate invalid instructions. At the same time, that's also kind of dangerous because we might generate instruction streams that have like jumps that jump way out of the instruction stream. We also don't want that stuff. So that's the other reason why I want to do something targeted. Although at that point, what I might be able to do is something like, yeah, I'm not actually sure, but yeah. When we get to things like jumps and branches, which I actually don't want to test yet, I want to save those for later. What I think I want to do is take the generators that we'll build and then generate some like basic blocks and then have random branching instructions between them, sort of flatten them that way. And I think that would be a really good way to do it because then we always know that we always know where things are going to be jumping to. But at the same time, if we branch things a certain way, then we can still have like one correct code path through all of that, which is going to be important. So that's sort of all the stuff I wanted to go over before starting this. Michael McMillan, do you wish you had this test rig from the get-go? Yes, I totally do. That was another thing I've been thinking with this. When I started this emulator, one of the things that I started out with was the debugger. And the debugger isn't great, but it's totally good enough for not being blind when debugging the initial implementations of things. So if on the next emulator I do, even when we go back to N64, I think what I'm going to do is make a debugger first and then try to make one of these rigs as soon as possible. Because I think it would have saved us a lot of time to be able to do this testing really early on. And it really, like, it took a couple weeks, but think about how long it takes to reverse engineer some of the ROMs for this and how difficult that is compared to building this rig, which is a repeatable process ideally. So it would have been nice to have this at the start. Now, granted, I also didn't have a flash cart for the system when I started this emulator, so that's another reason why I didn't do it. And I also thought about doing these kind of tests before, but I kind of held off on it for a long time just because I knew they'd be so tedious to run on the system with swapping out the ROM. But because we have this rig, then it just makes perfect sense to do this. So yeah, I think in hindsight, it would have been nice to have this earlier on, but yeah. I would also like to document it fairly well when I'm done with this, because I think there are definitely other systems that this kind of testing would be perfect for. I know Game Boy would be awesome with it. because it also has a link port that's almost identical to this one. So like the protocol would be almost exactly the same, except the timing would be a little slower. Super Nintendo, I know, can do this. N64 can surely do it, especially with the carts that Marshall makes. I can't remember the actual name of his company, but they have built-in serial ports in some of these test carts. In fact, the Super EverDrive does as well, I think. And with that, you don't even need the custom rig, and then you can run exactly these kind of tests. So, I mean, the thing, Michael McMillan, it does suck a lot of the time, like, because you just have to go through all the instructions. Now, with a RISC CPU, it's actually not as many instructions, but it still is a pain in the ass. And there were a couple bugs. If you look at the Rustro Boy blog, there's one about when I fixed these ship things in Vertical Force. And that was actually really hard to track down, even though the bug itself was super simple. But yeah, it is part of the game. It is part of the fun, because there's that feeling you get when you actually fix it that's just amazing. And I'm really hoping to get that feeling in the next couple days. If not, I mean, at least we're on the right track. And having this kind of test suite is super valuable. Like, I've been thinking about and looking at some other Virtual Boy emulators throughout the process of doing this, and looking at a lot of the code to, compare it with ours and see where different bugs might lie. And there's a couple things that I will totally say about this emulator. First of all, the top level bootstrapping of this emulator is one of the simpler ones. I think the architecture is a little more thought through than a lot of other emulators. The video hardware that I have right now seems to be the most accurate of all the emulators that I've seen, especially in timing, because we did a lot of that work a couple months ago. Just at least measuring when certain events happen. Even with those sort of crude tests, it seems that we actually got a lot of value out of them. And like, if you look at, I'm thinking about doing comparison videos once I fix these CPU bugs of Rustro Boy with other emulators, because at some point I actually want to do a big push to see if I can get this to be like a proper libretro core, and maybe get it to be like the default libretro core, just because it's a lot more accurate than a lot of other emulators in a lot of respects. So I want to do things like, if you look at the intro to Space Invaders, for example, it's total crap on a lot of other emulators. Like, it just doesn't play it at all correctly. And there's a lot of other instances of that as well that this emulator already handles correctly. So yet more reasons why I think the bug lies in the CPU still. And then also, because we'll have these regression tests, it should be possible for another emulator author to sort of port their emulator to fit these regression tests as well and use those. So it'd be a cool thing to contribute to the community. But yeah, it should be really cool. Yeah, that's cool, Michael McMillan. If nothing else, I should be able to show that if I can do it, you can definitely do it. Hey, Tony. Like, I think, again, one of the most important things here is just having visibility over the system, which is, like, you don't optimize without profiling. And in the same way, you shouldn't, as much as possible, you should try to get visibility over a system like this, because it's just a lot of details to put in the right place. And visibility will just really help. And these tests are exactly what's going to give us that visibility over the CPU instructions. So I think it's about time to do this. Right now, I'm not really going to care about how, like, the architecture and all that stuff's going to be set up right now. All I really want to do is just kind of start hacking this. What I think, so I was thinking also about, like, what is the test framework going to look like? And I would kind of actually like to use Rust testing framework. So I just kind of want to try this. Test. And I think it's config test. And what do we do here? So we're going to basically do this. Hey, Chief Detector. So what I'm thinking, I want to use Rust testing framework, because then we can do things like assert this. So our test would look something like this, and then we can do expect here. Now there's a couple things we're going to have to worry about with this, but oh, it's just test. Cool. Yeah, the config test is what you mark like modules and stuff. Yeah, you're right. So one of the things about Rust testing framework is that it will, it's going to multi-thread the tests, and I actually think that's okay. If we put the hardware port behind a mutex and then have it be a new mutex of option none at the beginning, and then the first one that grabs the mutex also sets up the port, I think that will actually work, because then we'll basically have multi-threading on all the generation of the fuzzing code, and also on the different emulator test code, because we can actually just make different emulators for each test, and that would actually be probably okay. Or maybe we put that part behind a mutex as well. But then we can basically multi-thread like the generation parts, and then we'll have, of course, a bottleneck around this hardware thing, which has to be sequential, but I think that's okay. Yeah, I can also do test threads 1, but I think I actually want to do I think I want to actually do this multi-threaded, because we have to make like the hardware port global anyway, and then putting it behind a mutex is super easy in Rust. So I think that's what I want to do. Now I would actually love to have both of these behind a mutex, both of these behind their own mutex. And I think the reason why I want to do that is because then it will actually schedule these nicely. So like one thread will be doing this. Actually, it'll probably all still wait on the, like, once the pipeline gets going, I think it will have like be running one test on the hardware port and another one on the emulator port, and it'll kind of work out that scheduling for us, which should work. Yeah, that's it, Chief Detector. But this is what I want, so you're right about that. Yeah. So let's do this. We need to set up a couple things here. I'm going to make a bit of a mess, and it's going to be fine. Because let's do, I think it was Rust static variable. Rust global, because there is a way to do this. Yeah, and so, okay, it's funny, because actually someone is doing exactly the same thing. So it may be an issue, because I don't think we can do any heap allocations during this, which might be okay. But we're basically going to have something like this. Static mute hardware port, which is going to be a mutex of option of serial port. And it'll be none. And I think we actually need an arc here too. Or maybe we don't. I don't know if that's actually reentrant. But I think it works out, because I think the arc is just if you need multiple owners. Can be statically initialized, which would be interesting. But yeah, I think this will mostly work. Let's see what errors it gives us. Yeah, so we need mutex. If we can't get this to work, I'll just single thread the test, but I would kind of like to do it this way. Yeah, we need serial port, which what did TNC Connect give us? A box of serial port. That's fine. We can do that. And that is from serial port prelude. So go ahead and pull that in. And then I do think that needs to be boxed. That'll fix the static size stuff. Okay, so this actually should compile. But I think I do want to look into lazy static here. Just because this whole option thing is because we want to initialize with the first one that grabs this. Although I don't know if that works with threading. But I actually don't think we need this. I think this will be okay. Just because I don't want to run into threading problems if that has threading problems. Or actually, let's just search that. Lazy static Rust thread. It doesn't mention anything, so I'm... Oh no, here, DREF implementation uses a hidden static variable that is guarded by an atomic check on each access. I'm actually going to look at the source. Because lazy static would let us get rid of the option here, which would actually be nice. Actually, it looks like it's going to be okay. I'm not actually seeing the code that would make it okay, but it is saying that uses spin locks. Nice try later. So then I think, because then we can get rid of the option there, which is super nice. And then we should be able to lazy static this. Let's see. So let's do this. We do our macro use. And then around this, we still want the mutex around this. But here, don't need mute here actually anyway, because the mutex is going to be mutable. And here we can do this. How neat is that? It doesn't like the pattern here. Not sure why. Whoa. Okay. Serial port cannot be sent between threads safely. That's annoying. Just to make sure it's not an aliasing problem, which I don't think it will be. Yeah, that's not fun. Okay, then we have to single thread this. Because serial port can't be sent. Not ideal, but happy to find that out now. So then we can still use Rust tests here. What we're going to do then is we need to not have this behind a mutex. And then I think this will work. Okay, we still need send for lazy static. You know, I wonder actually. I wonder actually if this would have worked without lazy static, and lazy static maybe like tries to create it on the thread and then set it. But then we have destructors and statics, and that's unstable. Oh no, but that's fine. It's actually fine if we do this. Again, if we make this an option. I really want this to be threaded, you guys. No, and then it's, yeah, because this still would be the same case where to destruct this, yeah, that's going to be an unstable feature. Okay, then we're not going to do this. All right, now I'm convinced that this is not what we want. So then we're going to single thread the tests. That we still need. Worth a shot. So I still want to use Rust testing here, and then I think we do. Is there a way to do test threads? If there's a way to specify that in the cargo manifest, that'd be really rad, but I don't think there is. I wonder if we can just set environment variables in cargo. Because like I just want to make sure that if we make these so that they can only work single threaded, that that we can enforce that. Thread local is not what I want. Because that means it can't leave that one thread, and that's kind of the point here. I mean, that'll work in terms of making it global, but at that point, we can just do a normal static anyway and just use unsafe. Which is okay. But, I mean, the other alternative, though, because that's kind of what I'm not liking here about the test threads. I don't know if we can enforce that. I'm not seeing any way to set an environment variable from cargo. So it may make the most sense to just do the testing part ourselves, which is not hard. It will mean that instead of using assert, we're going to want to return a result from all of our tests, which I think is fine anyway, because all the code's written for that. Yeah, that's the thing Dissy used. For multi-threading, we could actually have it test the hardware and the emulator in parallel, and also when it's generating all of the random bits of code, that could have also been parallelized. But I don't think that's too important. So then we'll have something like this instead. And what did I have for the result type here? As a command error. We can just do string. That's fine. Then we can make our own assert if we want to. Here, this test index thing doesn't make as much sense anymore. I'm gonna tear this up. Hey, Daniel Collin. Now, the one thing that kind of sucks, though, is that I was hoping to capture printing from this. And the thing is, what I don't want to do is reinitialize the connection to the Virtual Boy or the emulated Virtual Boy for every test. That's one of the things I'm trying to avoid here. But it's not really going to matter if we have long test logs. It's not really going to hurt anything. Because we can scroll. I think we'll be all right. But we will get to fuzzing today. Do not worry about that. Yeah, this is just the other function I had. Don't really need this, do we? No, we don't. Yeah, that with no capture, that would give us the same result as doing our own tests. So I think that font face is either in my FAQ or it's just the default. I don't really know why so many people ask about my editor. It was like a weird thing to ask. No offense. So I'm gonna just get rid of all this. Rid of a lot of this stuff that's being used here. We want ran later. So we'll also have to be doing some of the bootstrapping here by hand, which will also be kind of annoying, but it shouldn't be too bad. This, I think we'll do this too. We'll probably need to do map error. Like that. And then this should end up being something almost there. We need the ports to be sent in here. And maybe that's actually nice that all the tests have to accept the hardware port and the emulator port. It's better than having global variables. Actually, we just need this. This actually had this, which was... No, the other function had that, didn't it? Let's do this. Sometimes I'm cheeky like this. Undo so we can just copy this. And then redo. Ayo. And then... So we end up with the same thing here, just with mapping errors. And then the ROM itself we need to look at as well. But that's actually what's going to be different here. Because we're going to generate the ROM. So I think that's okay if that breaks right now. This we can get rid of for now. Actually, I'll just get rid of the whole thing because it's trivial anyway. Don't need file. Don't need this after all. Yeah, just doing our own testing harness here is fine. And then I want to do... We'll do our own assert EQ because that's nice to have. Just as a function, so it's not ambiguous anyway. And then what this can do is this can return a result of this or string as well. And make a couple types here. And then actually these both need to be the same type, so we'll do T. So A and B are T, and then T also needs equality. And so then what we can do is if A is B, then it's just OK of nothing. Otherwise, let's do EQ and display or debug. That in order. And that way we can do this. Or error format. Assert equality. Failed. For these fuzzing ROMs, I'm not going to do that, Daniel Cullen, but I totally will set that up when we do like C and assembler ROMs later. I want to have it invoke building, so then we can just change the source and not have to go through command line to build those. Also, that would work on CI. So yeah, eventually I want to do that, but I'm not going to do that today because we're just going to fuzz some flat binaries, I hope. We need SD format debug for this. Hey, Matrix. And so then we can do is this, and B was this, and we need these to be debug. That's pretty cool. So then we can do assert EQ. Actually, we should just be able to remove this and remove this. And then, yeah, it's going to complain about the ROM, but we're going to generate that anyway. So I think we're going to be okay. I also want to hide this behind a function, I think. So something like, I'm just going to move this around. Yes, we end up with the same thing we had before. Actually, let's do this. Let's do it this way. We'll call this test ROM. And then we're going to have this take in the ROM, which is going to be that, I think is all it needs to be. And then we'll do test here, which is going to be our actual test. Now, the signatures here are not that great, but it doesn't really matter because we can copy them. And then here, this will be test ROM, emu port, and then the ROM. And it's probably going to be that due to the way we generate it. And then we need to generate the ROM here. So we could do, for example, let ROM is vec new. And this would actually compile, I think. Oh, yeah, we need this. And then what didn't it like here? Oh yeah, we need debug, not display for those errors, which is cool. Rad. And then what we can do is, I think, just make a bunch of pointers to these functions. And that can be how we bootstrap our tests. In fact, I think we can even do it without listing the types. So we can do like let tests, just do an array of them, I think. And then for test in tests. And I think we can do test. And then here we want to do match here. Because if we get OK of this, we want to do a couple things. We're going to do let mute pass tests, let mute failed tests. And here we can do pass tests, increment that. Otherwise, if we get error, Senior Kai, thanks for the follow. Need to bump my window size up here. I think that's more or less what I want. We need failed tests. should do test.len, pass tests, and failed tests. Ruh-roh. What a long error. But it's telling us this, I think. I think that's okay. So if we just run this now. Then it worked. And it failed. Yeah, hardware dispatch failed because the data was empty because we gave it an empty ROM. That's actually really cool. That's actually totally what it should have done. So this works. I think what I'm going to do, though, is actually not have it print this stuff because we don't actually need it to do that. Since this is always going to break on the errors anyway, and that should tell us what goes wrong. So I'm actually going to get rid of a lot of this printing here. Which we don't need. We do need to prepare the result regs. That should be it. So then here, we don't need to print these. Or that. And then we can get rid of this. Yeah, so it's not that bad to have our own test framework because it doesn't need to be complicated. And in fact, the next thing I want to do with these tests, I wonder if there's a way to get the name of a function in Rust. I don't think there is. And then we may just have to add those by hand, which is not terrible because they're just going to match anyway. Like if there were a macro to do this, that'd be great. I remember looking this up the other day, and there were some RFCs about it, but it wasn't really being looked at. Yeah, don't think we have that. That's fine though, because we can do these like this. We may have to specify a type of that, but we'll see. And then this can do. So the test will be this. Test function, test name. And yeah, that makes sense to be used. But it would have been nice to have like a macro, and I could just give it the name of one of these, for example. Like the current function name I understand, because then it may not have names for a lot of the functions, but to get the name of, like, if I tell it to give me test and it'll just give me the string of that, that could work. You know, I can probably just do that with macros, can't I? Yeah, exactly, Daniel Collin. One step ahead of me. I think I'm going to do that, actually. So I'll make it work with this first, and then I'll macroify this because then it'll work, because then we can just use the symbol to make a string with the Rust macro, and that's good enough. That's I'll be happy about that. I think that'll work. We may have to specify something here though. We need ref here. Is there one to see used? That's even better. I always have to look up how to do macros in Rust. I never remember. I rarely use them. sometimes they're really nice. And this is a place where the macro is going to be simple enough that I would like to have it. Yeah, and C with just textual replacement, it's easy enough. But in Rust, it also won't be that hard because I think I just need to know. I think I just call this expression. I need to know what, like, the macros in Rust are typed, so I need to know what type. Oh, it's identifier. I think is what I need. So it should actually be really easy here. In fact, I think we can even do the macro in here. We do macro rules, and then we'll call this test. And then I think we need, for example, do name, which is identifier, and that's going to end up being name, and then we want to do a string of the name. Which we have stringify for. That's the one. That's probably the macro you were talking about, Desu used. And then we can get the name here as well. And I think that would work. And then we can do this, which is kind of nice. Oh, yeah, and this is not a string. It needs to be an identifier. That's pretty good. And then let's just do something like this. Actually, I do want to bring back std out here, because here I want to do std out dot flush dot unwrap. I think is what it is. Perfect. Last thing I'm going to do is just print an empty line here. Yeah, and I like using macros for these small cases. I think that's pretty nice, actually. Nice and easy. So this is going to get super bloated, but that's going to be okay too. I think this actually could be static. It's going to be immutable. It might be nice to have it sort of outside here. Does that work? Oh, I need to specify the type here. What is the type here? We're probably going to have a static string for the name. Or static string ref for the name, and then let's see. Rust closure types. Another thing I have to look up. Let's just do function. I think that's the most general one. Yeah, I think we can just do function. I think what we do is this. Can we do generics as closure types? I don't think so. In which case, we might need to box these. I don't think it liked that. Because we could box these and have dynamic dispatch. And then the function signature gets simpler, because then it becomes just a function of box read write twice. Like that. That if it likes that, I'm gonna just box these and it's gonna be okay. Yeah, so we actually probably do need type specifiers here. Yeah, if I remember correctly, actually, to do these functions, like the functions themselves are compatible with closures, but the types get a bit messy. I'm just gonna have this in main. This is gonna get a little nasty, and it's not really that important. I mean, what I could also do is I could also make every test be an object that implements like a test trait, and that would be okay if I need to split this up. But for now, we'll just do this. So nice modifiers. Anyway, it is running the test. This does look correct that fails. And one last thing I want to do is just put some quotes around that, make it easier to read. And we're looking good. By the way, the reason why I'm running in release is because the emulated Virtual Boy that we're running the tests against is super slow in debug. So this saves a lot of time. But yeah, I think this is all we need for the framework, and now we need to start doing the generators. So this is where things start getting a little more interesting. What I want to do, let's just write this down here. I want to do a generator, and I think it will basically just have next. Now we need to have it return, or at least append to a vector. I think that's the easiest way to do that. I think that's by far the easiest way to do this, is just have it append to that directly. Because otherwise we're going to have the generator returning, because here's the other way, is that this can return a vector of U8s or a boxed array of U8s or box slice. What did iterate next give us? I think the same thing, except that it would be option. Yeah, it's option of item. I actually like this. We can just return arrays of bytes. Metal Voids, I'll be streaming. What is it? Oh, it's almost 2 o'clock already. Dang. I'm only going to be streaming for another hour and a half or so. So not too late, I guess. Alternatively, this could return an instruction, and then we could separate the generation of semantic instructions from their bit representation, but I don't think it's going to matter because we're going to have to write both anyway. So I think I want to do this. And then to use a generator, you just concat a bunch of these. And then probably having it evacuate, even though it doesn't need to be resizable, is probably a little more convenient. May not be. I'm not sure. We might have to play with this. But then I think what we can do... Actually, you know what? Because what's going to end up happening, this is actually the better way to do it. Just thinking about the usage, because what we're going to do is when we implement this, internally, we're going to probably make a vector and then append some words to it anyway. So it's probably more convenient to just take the vector in, because that makes the usage and the implementation both a little bit simpler. And since we don't really have to conform to any particular interface, picking the one that's best for us is the best choice. So then we do let mute rom is vec new. And then we can do something like this. Now I want to do a couple generators here. We need to do ret generator. Now there is no actual ret instruction. It's just jump R31. But we need to be able to specifically generate that exact instruction. So I'll just call that ret. Why don't we just call this ret too? Because that's actually kind of cool. Because then we can, actually this is nice because we can do create the object .next in mute rom. And that'll just give us one that only contains the return opcode. That's probably pretty cool. And then we also need, we'll take a mute self here. Even though we don't need that in this case. And then we just need to push the right stuff onto here. Now I don't remember the instruction encoding for this. Oh yeah, we need the name. Buff. And yeah. I want to do this from the data sheet, not from our emulator code. Even though our emulator code would be probably easier to read, I think it's smart to take as much as we can from official docs while doing this. Pull up the architecture manual. Instruction set. Particularly, we need jump. Jump with R31. Thought that'd be in one of the appendices. Might be looking at the wrong sheet here. Probably am. Oh, that's annoying. Let's do the data sheet. Come on, where are they? It's been a while since I looked at these documents, apparently. Was I not looking at this one earlier? Yeah, I'm just looking at the wrong parts of this. It's been too long since I looked at this. Because I really thought it was in the architecture manual. .5.3 instruction set. Okay, it's here. So we need to find jump. These are in alphabetical order, which is nice. And we're just going to generate a jump to R31. And we're only going to have it run that as our first test. So the nice thing is it's actually a really simple instruction to generate here. So I'm going to pull this down, but it should be there's our opcode. And then we can do, we're going to make a couple helpers here. For example, do buff dot, or we'll do it like this, push U16. We'll take the buff and then the operator shift left 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, shift left 10 or this. It may make sense for us to actually have some helpers for generating different instruction types as well, but this will be good enough for now. And then we can do push U16 where our buff is a mute vec. Actually, can byte order do this? It should be able to, right? Maybe not to a buffer. We might need a cursor for that. If we do, then I'm going to just make this one for the vector. Oh no, it actually does support that for vectors. So that's actually pretty cool. So then we can do, don't need this. Here we can do buff dot write U16 little endian, and we can do unwrap here. That's gonna be fine. And then we'll do again op shift left 10 and we need reg 1, which is going to be 31. I think that's all we need for that. So this should actually work. And this will be our first test. First actual test. Bam, that passed. Sick. So we are on our way. We'll call this ret test, or just ret even. We'll call it single ret. Oh, that's nice. So which instruction do we test first now that we have ret? Because what we're going to need to do is for all the other generators, we need to generate like a big instruction stream, and at the end we tack on one of these rets. That's why I did this first. Oh, that's so cool, you guys. Oh yeah, I've renamed it. Or single ret, I called it. I could do them in order of opcode, but I kind of want to try doing some more targeted tests. Like I kind of want to test multiply. Because I just have a feeling those might be a little janky. Divide I don't yet, and I think it's because it can generate a 0 division exception, which I don't have implemented, so I don't want to do divide yet. Oh, and the other thing is, here's the other thing. I actually need to do like loads and stores first in order to make any of the other generators make any sense. Because otherwise they're just going to be generating like a bunch of well, actually the initial register values would be enough, wouldn't it? Yeah, actually, so that's fine. Because that's the other thing that I wanted to do that I forgot about. This test ROM thing sets up these initial regs. We don't necessarily want these values. We want different values. So let's actually do it this way. We'll have the test ROM on port thing take the initial regs. We can have it take initial regs and then still serialize the initial regs bytes. ROM adder, and then initial regs, which can be a thing of reference or U32 slice. Yeah, because we need to put this in our test as well. Yeah, yeah, Blambear, I did. The Russell Boy interface is also working with these tests right now. So we're already testing against both, which is pretty rad. So now test ROM needs some initial regs, which we could do this, for example. Kind of want to make this random though. So let's actually look at our options for seeded random number generators. Rust RNG. Or Rust Rand is actually what we're looking for. Now, I'm fairly certain, because there's an RNG trait, which I think is implemented by a couple different kinds of generators, if I remember this crate correctly. So we don't want like thread RNG. We want something that we can seed. Like, for example, standard RNG. Although I don't know if we can seed this. We can do reseed. But maybe there's something simpler. Zor shift. Okay, so reseed actually takes like 4 U32s. I think this would be fine though. Let's just do Zor shift. Not suitable for cryptographic purposes, but it's very fast, which would be good enough for this. We don't really care about it being that nice. Oh, STD RNG had from seed. What did the seed look like for STD RNG? Because using the one that says STD sounds nice. Yeah, it does have from seed. And then, okay. Gotta read a bit more about the seeds. I mean, I guess we can just put whatever we want in there, can't we? If it doesn't give us any... Oh, it's a single U size, isn't it? No, this is a slice of U sizes, so it doesn't really tell us what it needs, which is fine. So let's do that then. We'll do STD RNG here. Rand, we're gonna need the RNG traits. STD RNG. So then we'll do something like this. And since it didn't tell us what it needs, we get fade babe. And then, okay, didn't like that for some reason. Seedable RNG for STD RNG. This should just be an associated function, so I'm not sure why it didn't like that. Does that mean I do seedable RNG? Maybe that is how that works. Because I guess that would make sense if this, when you have an associated function like this that's implemented by something else, it just means that this is able to return this. don't even need to do that then. Oh yeah, actually we do want to do that. We may have to specify type here. Yeah, so for example, this needs to be an STD RNG. I can't remember what the literal postfix for usize is because it needed a usize, I guess. Maybe it's that. That's a bit odd, isn't it? I don't understand how it doesn't know the type here. For example, reseed is the same thing. It'd be weird if we needed as usize there, but maybe that's the easiest way to do it. Huh. Kind of a weird way to do this, but this syntax here. I guess that just allows us to annotate the types well enough. Okay, anyway, what we want to do here then, we can do 0 to 30. And we can map these where we do RNG.gen U32, I think. We need our turbo fish. And then we can does 2vec work here, or do I need a slice for that? Yeah, I didn't find that. So let's do collect. And I think that's actually no, because this won't know that it's a vector, so we need to do collect into a vector. Nice, you see, Berlin. That should work. And then what I actually want to do here is break the test so that it prints out what it was going to be. And that looks pretty random to me. So I'm satisfied with that. And if we run it again, it should give us the same result. And it does. So good. I'm convinced. May want to abstract generating random register values as well. But I think for now this is fine. Actually, let's do that. Just be anything that does RNG. Here, I'll actually have this comment here. So gen couldn't be invoked on a trait object, so let's just do std_rng here. And then we might even be able to remove this type annotation. Do it this way. There. So here we have, there's our ROM, here's our initial regs, and then it tests them on the different ports. This is not a terrible way to write these tests by any means. If we have 50 of these functions, I'm pretty happy. We are going to want to change the seed for a lot of these. Maybe this is what we want to do. Maybe we want to take the test index as a parameter here, and we can use that as the seed. Just so we don't have to sit here and make up a bunch of numbers. And then it would change if we reordered the tests or something, but I don't really care about that. As long as we can make regression tests at the end of this. Because as long as I can test against the hardware, it's going to get the correct results. And we can have it automatically update the refs if the hardware results change. So yeah, I'm not too worried about that. Let's do that. We'll take a U32, even though we need that to be a U size here. Something like this should work out. Oh, that's U size there. And then that makes sense. And then we can do the test index here. Because if we do test.iter.enumerate, then we should be able to get an index. And then this. This and here might not fit, but we'll see. And actually, I think that'll give us a U size here. Just because I think that's what iterate or enumerate does. And then this gets to be even nicer. Index. And then we can do this. Because I kind of liked having the index here. And that's pretty good. I like that idea. We'll see if it's a problem when we give it 0, but I don't think it is. Cool. So we have a passing test that just generates ret and actually returns. And you can see the fact that the Virtual Boy actually still works is a good sign that that is actually returning properly. Because if that wrapped around and ran into ROM or did something really crazy, the Virtual Boy would probably crash. So this is a good sign. Yeah, I actually am pretty happy with this setup. So now let's go ahead and test. I want to test multiply. Because I really have a feeling there might be some jank in there. All right. So we'll start with mul. Yeah, I'm only going to be able to stream for another hour, so if that. So start doing this a little targeted. But I'll stream a ton tomorrow, by the way. I think I mentioned that several times, but I really want to. So single ret works. Let's do mul. And there's another couple. There is also a generator I want to make that just takes a bunch of other generators and then takes random bits from all the different generators. So I think that'll be cool too. But for now, not gonna have to worry about that too much. So in this case, we actually want these other generators to be random. So ret will always generate the same thing. That was kind of the point of that generator. But mul, for example, will need an RNG here. And we'll just do an std RNG. And so we need to impl mul, function new, give me a mul, and we need an RNG, std RNG. I at least want to take in a seed here. I'd rather take in the whole RNG, but I at least want to take in a seed here so that we can see this properly. And this is also why we want mute self. So this actually makes sense. And the nice thing about this too is, I guess we could also pass in the RNG to next, but I'd rather, this feels a little cleaner to me. Yeah, this will make sense. So again, this is another simple opcode. We're just gonna do op is 00100. Again, I'm just pulling this stuff from the data sheet. You know, I wonder actually, Sigmofo, thanks for the follow. I wonder if it might make sense to dump these to disk and look at the disassembly of these. Maybe it will for debugging. Because it would actually be really nice to look at these before I run them, but yeah, maybe I want to do that to a temp directory so that it would just automatically always dump the ROMs, and then we can go in and look at those in an easy way, just with obj dump. Although it's going to be a flat binary, so I don't know if it'll dump properly if it doesn't know where the code starts. Maybe that's fine. I'm not actually sure. Let's not worry about that yet. But I would just love, especially as we're setting this up, to look at it and be like, okay, if I make a generator and I generate 1,000 random instructions, it would just be really nice to look at the disassembly to see, oh yeah, that's all muls, and then a ret at the end. So yeah, maybe we'll do that. I'm a little indecisive today, but it's fine. And then let's do this, because we'll do let reg1 is self.rng. Okay, nice. Yeah, that's nice to know that that'll work. I'd rather use those tools than like hook up our own disassembler in here, even though the emulator has one. It's just going to be easier if we dump them to disk, because then we can just check the ones we care about. So yeah, let's do RNG gen, and we want a, we'll do it as U16s here, because that's fine. Or actually we'll do U32 and then we'll just cast. And then we need to, I'm going to do modulo because I like the semantics that it's modulo 32. This should be able to strength reduce. And let R32 is, R2 is going to be the same thing. Now we need to be careful here because we don't want to clobber R31 when we do our tests here. Don't include R31. And so that's also why I want to do the modulos, because then we get the symmetry here, which is pretty cool. So then the actual instruction is really easy, because then we can do, oops, what do we do for ret here? This guy. And so we have op shift left 10 or reg 2 shift left 5 or reg 1. And we'll do as EU16s on these. And so here you can see already that instructions of, I think these are two of the same type of instructions, mul and ret. So I think like the serialization here is basically identical for them. It's just that this register was hard coded. In fact, if we did like if we wrote this out, reg1, let reg1 is R31 or 31. Then you can see it's basically identical except it's missing reg2. But yeah, the reason, by the way, that we don't want to include this in reg2 is because reg2 is the destination register. So we can have it read from R31, but we never want it to write to R31. Otherwise, we can't return. So that's fine. And then we have no exceptions. And then we have very specific flags, which is really nice. That's the kind of thing that I want to test with this. So with this, we should be able to generate a bunch of muls. And so now let's actually write that test. So I'll just copy the single ret thing here. And we'll call this multi-mul. Or let's call it muls. And we still want to do this. We want to do ret.next with ret at the end. But first we want to generate a bunch of muls. So what we can do here, do something like this. Just to offset this so that we get different RNGs for this. Or here's even better. Whenever we make a new RNG, we do this. We do RNG dot gen usize. And I wonder, that's pretty cool. Except we need to make the RNG first. That. And then we want to generate a bunch of these too. What? That should give us a usize? Thanks, shadowing. Are you serious? Don't really understand what's going wrong here. Type of what value? It's not like RNG, maybe? Yeah, that's totally what it is. That's what it's going to be, because here it knows RNG, the type of it, because of random regs. Here we need to make that explicit when it calls RNG here. So it's complaining about that. That makes sense. What didn't it like here? Oh, no. Our function items are wrong here. But can we do a reference and have it work out? No, because then it still needs to match those. We can probably, I think we can fix the types there in a sec. We'll get to that. But yeah, the initial regs here, we want to generate the ROM. So we'll do I don't know how many instructions we need. Let's do 4,000 of these. And we'll just see how that goes. This should actually be pretty easy because we can do this. Let mut mul is mul new RNG. And then I'm actually going to create the ROM first just because I think that'll look a little nicer. And then we can do mul.next mut ROM 4,000 times. And that should actually give us a pretty good ROM. Yeah. So yeah, because these different function items, they had different types because they're different functions, and that's pretty typical. So what I think we want to do we need to specify the types here. So this is going to be, we need the length too if it's going to be an array. So let's make this a vector. And this will be a vector of, I don't think it's that bad, Matrix 404. There'll be about 50 of those. And then we're going to have a couple that'll just take all the generators and generate like a lot of stuff. Or maybe you mean it's a lot of work to run 4,000 instructions, and then I very much disagree because we have a lot of different combinations. Should be 32 by 32 combinations, at least in terms of how many different kinds of the instruction we can generate, which is at 1,024. And then remember also that the initial register values are going to be different as well. That's going to matter. So I want to run more than that as well. So I think it's a sane amount of work. But also, after doing that math, I just realized one of the things we might want to do with this too is not only generate a bunch of random ones, but also generate specific ones, because it looks like we can cover the entire range of values. So at least hit all the different kinds of encodings for that instruction, like all the register pairs. But then, yeah, anyway. So this is going to be a static string ref. And then this is going to be, again, a closure. What if I just do this and hope that it works out? Because those do end up being the same, actually. Oh, look at those errors. Woof. Woof. Oh yeah, size is not satisfied. That's easy. We can box the function pointer and add that in our macro. If that was the only problem. Oh yeah, and then we need this to return result of this. Okay, and then it couldn't move this out of borrowed one. I think that's fine if we do into iter. Expected tuple found reference, because now we don't need the reference there. I don't think it's that ugly. I think oh yeah, and then remove tests here. So that's easy. Let mut num tests. Yeah, I don't think this is too bad at all, actually. And this doesn't need to be mutable. Thanks, Rust. All right. Yeah, because now it's a bunch of boxed function pointers. So instead of just being the yeah, because I think the function pointers end up being fat pointers in case they're closures. Yeah, that's what it is. It's the closure pointers need to be boxed because they're fat pointers. And so these will actually get automatically cast to the closure type, which I guess is just like an empty closure object, and then the function pointer as a fat pointer, which is then boxed. And then Yeah, no, I think this is actually fine because it lets us write this, which is really nice. And it's not that ugly. At least we get to use type inference for this part, which is where I got stuck earlier. So that's actually pretty cool. So if we just run this, what happens? I actually kind of suspect our protocol might not support running this many instructions just due to how long it'll take. It might be okay. Okay, wow. The emulator didn't respond to the handshake, so it got stuck somewhere. So it's kind of interesting because it is moving. It is running a lot of stuff here. You know, I wonder. I think I know what's happening here. Actually, that's not responding to the handshake. I think we need to allow more retries when we're letting it run the code. So in order to test this, I'm going to drop this down to 4 instructions, and it should work. And then I'll kind of explain what I'm thinking here. Yeah, so that actually worked, and it passed, which is rad. And then as we bump this up, what we actually need is for the test here. So it executes the write mem region command, it executes the execute command, and then it's going to start executing the read mem region command. And this will not work unless the Virtual Boy is done running the test. And we don't really have any way of knowing that it's done other than the fact that this works. So I'm going to do this. We're going to just have a bunch of retries here. We can break out of it this way. So yeah, do this. There isn't yet GC Berlin, but there might be later. The issue there is like I don't have instruction trap exceptions or anything implemented in the emulator yet, and so I'm going to hold off on that for now at least. But maybe at some point I'll do that. I mean, since we have this setup, it totally makes sense. So, but not going to do that yet. The first step of that would just be to just send an entire random buffer to it, but we have to be careful about jumps. So maybe we'll want to be a little more focused about that. Depends on the encoding too, though. I'd have to look at that to see how many spots there could be for different kinds of encodings like that, or like different possible holes in the encoding, I should say. So let's So if this didn't work, then we're gonna do this. Try supposed equals 1. If tries is greater than or equal to, I don't know how many we need here, so I'm just going to put 5 here. We're going to just play with this value till it works. Then we're going to do return error of E. So that's simple enough. Oh, yeah, we don't need the parens here. We'll try that. I suspect that's not going to be enough, because we want to be able to run a lot of instructions. Yeah, so still didn't respond. Let's crank this up to like 20. No, I don't want to sleep a little. And I'll explain why in a sec. Because this is the thing. Nice, Silverland. So I feel like I have to explain this a lot of times, and I don't think it's your guys' fault. But it seems to be something that it's hard for people who haven't thought a lot about it to understand. which I'm only bringing up because I find it interesting. But basically, the emulated time, for the Virtual Boy, like there are weights built into the protocol that are going to weight a certain amount of whatever, right? And sleeping, like adding a sleep here doesn't help us if we're going against the emulator. And the reason is because the emulated time doesn't pass when we sleep, because it's not like the emulator is just running in the background. Like we actually run the emulator in lockstep. So there's a big distinction between emulated time and real time. If we were doing this against the Virtual Boy, then that might make sense. But I'd rather just give it more retries, because that will also have weights built in and be compatible with both the hardware and the emulator. So it's one of those things that I guess it's hard to get your head straight if you haven't thought about that before. Because I feel like I have to explain that a lot, but it's not a problem. Just something I find interesting. So it's still not responding to the handshake. I'm going to do a couple things here. I want to crank this up to see where this breaks. I kind of expected that we might have these kind of issues doing this. Right, so there it works. And it passed. That's cool. There it passed. So let's do 1,000. I love how quick this is, by the way. So cool. But yeah, the point of all that little rant there is that I make a big distinction generally in emulation between emulated time and real time. And I think that's actually an important thing to do. So then it didn't respond, and I actually think we still just need more retries. I don't mind just having like a wicked amount of retries here, but it does make sense. Yeah, that's it, Chief Detector. Let's do 1,000 retries. If this doesn't work, then it might be something else. Yeah, now I wonder if it's not correct. In fact, let's do this. First of all, how big would this be, right? So 2,000 instructions. By 2 bytes each, it's only 4,000 bytes. And we should definitely be able to put that into the ROM. So it runs against both, but if it fails running on the emulator, it stops. So when you see it updating on the Virtual Boy as well, that's when it actually worked on the emulator. Oh, wait a minute. No, I do hardware dispatch first. So that's actually interesting. Wait a sec. Yeah, because this is running on both. It does. I forgot it does dispatch the hardware first. So it gets the results from the hardware is what we're seeing here. And in fact, if I crank this back up to 4,000, I'm gonna turn down the retries again. Like 200 seemed like a better result. Because if this works on the hardware, then we need to make the emulator work. Now I kind of have a feeling that here we go. So the emulated VB didn't respond to the handshake, but the hardware worked, which is actually really cool. So this could actually be a number of different things. I'm guessing it's issues with the protocol. It could be something wrong with the emulator, but I would highly doubt that because it should just be the same instruction. Let's look at the disassembly because I would really like to make sure that we're generating the right kind of instructions. But I'm guessing what it is the little bridge that I did that's running the emulator is probably wrong somewhere. And I kind of expected to have to adjust that, so not terribly surprised. But I think I do want to write this out to disk. Yeah, the kind of crap thing, though, is that we would have to write it out to disk explicitly. Maybe that's not that bad. I'm just going to adjust this a little bit. So where I would think it's going wrong here is that we're not stepping the Virtual Boy enough between commands. 10 milliseconds is a lot, but that's... I think we've seen worse overhead when doing full round-trip serial port transfers. Okay, so that is actually the problem. Okay, never mind. Maybe I can bump this lower, though, because that will save us time. The CPU will not give an exception as far as I can tell on overflow. Yeah, so we just need to simulate more time between commands in our little emulated Virtual Boy setup. Oh, so cool that this is working, guys. This is actual fuzzing tests running now. That is rad. But before I move on, this was 4,000. Let's do 16,000. Because I want to just see this. It should work. And you can see it filling up the memory on the actual hardware. And it worked. And now it's doing that in the emulator. Oh yeah, you guys can't see the emulator. And it didn't respond to the handshake again. I'm gonna adjust this one more time because this is the kind of way that we want to be stress testing this. I don't think we need test ROMs this big for like each instruction, but we could have them. So useful to have the Virtual Boy output there. Oh, what? Mini FB just went jank. I think I actually need to adjust the timing here a little bit more. But for now, let's just not have ROMs that big. Yeah, I just realized that. Maybe it's made more sense because you guys couldn't see the emulator. I was just reading the error came from here, that the emulated VB didn't respond. Then we got a protocol violation. And that's also going to mean some kind of error when working with the protocol. Ooh, wait a minute. There we timed out on the hardware. Okay, so this actually did work. I'm going to run this a couple more times. One of the things that I should do, like right now, the hardware test and the ROM test, or the emulator test, could totally be parallelized. There's a lot of instructions. And maybe I want to do that now. Hey, Durtu. Especially since I know the emulator can be sent to another thread just fine. The hardware port maybe not, but I know the emulator port could be. I mean, I just need to add plus send here. Maybe I want to do that. Actually, I won't do that now. I'll do that later because that's the kind of thing I can fix on my own. Okay, so Mole's looking good, and I'm actually not surprised about that. Let's actually do this. Let's do a sanity check here, because I remember, if you guys remember, there was a bug here. In the blog I wrote about this. This one, these enemies disappearing. And it was a bug in... It was either mol or molu or imol. I can't remember. Actual fix will just tell me the commit here. Mul. So it is in mul, right? So this was the fix that we did in the emulator to fix that bug. I'm going to break this in the emulator, and our test should fail. And if it does, it's going to feel so good because that's going to validate this whole framework. So look for mul. And yeah, this was the issue, was that we didn't sign extend properly. Let it run. Uh-oh. Okay, that passed. Now, that could have passed for a number of reasons. It might just be that the random test didn't cover enough cases. So now I'd really like to look at this assembly. Also, I'll look at our assert EQ thing here, which should still work. It just uses equality on vectors. Let's see. I guess since I just need it for this, I can just dump it out of the mul thing. Let's do it in here. Can I do use in here? Be funny if I can. And useful. Nice. Let's do this here too. Close the file right after that. Let mute file is file right, or file create probably is. Then we can do derp.vxe. For those guys asking what language it is, you can do bang lang in the chat, and you can also read my FAQ. Let's see. I think we can do write all here. And we can do rom.unwrap. And that should give us the file. Oh, nope, didn't like that. Why didn't like write? Oh yeah, because I need to unwrap this. I'm pretty sure write all is what we want. Although I think it'll flush before it closes anyway. But so then we'll go ahead and run this. And then I want to do an obj dump on the VXC that it pops out. So it already should have written the file. I don't need to let it run, but it should be cool. So now we can do, we have derp here, so we can do v810 obj dump. Should have that at least. Maybe I don't have that in my path in this terminal. Guessing because I opened that before I fixed my paths the other day. Yeah, that's the case. Dev projects VB fuzzer fuzzy. And then here we should be able to do v810 obj dump. And we called that derp. Now here we want to do -d. And I guess we need to make it binary. If we can do that. I still think write all is going to be okay here because I can't imagine the file not flushing before it gets dropped. I think write all is more like if you need to guarantee that it'll finish. Actually, no. Okay, no, I know what you mean. It can actually like return early or something. Yeah, so we actually do want write all just to make sure it does that. Let's see. Okay, so it actually looks like you can do -b binary. Well, I didn't see B here in the list of options. Okay, so we need the architecture. What does capital D do? Oh, let's disassemble all the sections. We also can do this adjust VMA, which is going to be that. Except I'm not going to break up my binary thing there. And then we need to say the architecture, I guess. Maybe that's -m. Yeah, it is -m. V810, we'll just try that. Ha! Cool! Look at all the moles. Look how sick that is. This is a lot of moles. And a jump at the end. Oh, this is actually really cool. This makes me happy how nice this looks. So the ROM looks very good. But I guess none of these actually had to sign extend properly. That's a bit disappointing. Oh yeah, I also forgot that it writes out the remainder to R30 and then sets the flags. Because it also sets zero and overflow flags, so I would have expected those to have been propagated at least. So it must just be that we have bad parameters for this. I definitely have a bunch of moles that can multiply by R0. And maybe that ends up zeroing out the regs. Yeah, it would result in a valid 0. Let's actually print out the results. The resulting regs, because if they're all zeros, then that could totally explain it. And then we would be able to catch this when we do the test that mix a bunch of loads and moles. In fact, we can do that next, is just add a bunch of loads too. So maybe there's a nice way to do this. Pepe Inferno Daxer, thanks for the follow. Yeah, it might actually propagate if we have a bunch of moles by R0. But I want it to multiply by R0. I want it to propagate some zeros, but it might be that it's wiping out all of them, which is bad. And in that case, I don't... Instead of like changing this test, I'd rather write another test that instead of just doing moles, will also do a bunch of register loads. Because that should also alleviate that. In which case, having this test be longer doesn't necessarily help, but I would still like to have this as an isolated test. So having this and then another test would make a lot of sense to me. But let's do this. do this. We know they match, so we can print either one of them. Oh, hardware dispatch failed. Let's restart the Virtual Boy. Oh yeah, that was for Rets. Yeah, that makes sense. For moles, the hardware dispatch failed. What? That's odd. I'm not surprised to see some intermittent failures. I definitely want to fix stuff like that, but I'm surprised that there was... It's a bit more often than I thought. Okay, so that actually worked. With the hardware dispatch, at least. Emulator runs. Yeah, okay, so that is what's happening. And, okay, this is actually super funny. Because all of the regs are 0, except this last one, which is the program status word. And guess what the 1 bit is? The 1 bit is the 0 bit, the 0 flag, so. Okay, but this is actually rad because, oh, cute little 0 flag. So it proved that we are generating good ROMs. So this is actually working. It's just that this particular test may not be the most valuable on its own. But I think that's okay. Let's go ahead and just turn down the size of this. Like, let's say we did, where'd it go? 8,000. Let's say we did 1,000. I think would still be a decent number. And just have it, whoops, have it run that again. Okay, so that even happened after 1,000. How many does this take? I'm curious. Like, let's do 100. Whoa, what? Hey, guys, check it out. Check it out. It worked with 100. Sir Skidmore, thanks for the sub. Look at that. The assert quality failed. That's actually exactly what I wanted to see by doing this, because we did break the mole instruction. Let me bump this up to 200, see if it still fails, because I would like to have as much as possible. And then you can see a bunch of these are still 0. Oh, this is great, you guys. Oh, it just makes me laugh. All right, we'll do 100 here. Oh, this is really cool, though, because this, again, proves the viability of the approach. So now we'll go back into... So let's imagine now for a second that we had actually just found a problem like this. Then what we can do is we can go in V810 here, and we can fix the bug. Like, we knew what this bug was going to be. And we'll run it again, and what's going to happen is it's gonna pass. Bam. How cool is that, you guys? So I'm going to go back here. We don't need to... I'm going to comment out the file thing because that'll be useful to have for later. And we don't need the regs thing as well. Oh, how cool is this, you guys? We are now running fuzzing tests. And just for fun, I want to dump the derp again. That's so cool, you guys. Oh, I love it. I love it so much. All right, I'm gonna go ahead and commit this. And it's already about 3, and I gotta go because I gotta be at the office at 4. So anyway, I won't be streaming later today. I'll stream for sure tomorrow. I don't know when, probably the same time. And no matter what, I'll go for a lot longer because my whole day tomorrow is devoted to this. And I think we should be able to make a pretty good amount of progress. Just doing this kind of stuff. Now that a lot of the framework bits are in place, I think this will move a lot faster. The mole's actually in a separate repo, because that's in the Russia Boy one. And also, yeah, we just fixed it, so shouldn't be too bad. So I'm going to commit this. And then we're good. So yeah, so I will see you guys tomorrow. And as usual, thanks for hanging out and stuff. Oh, I'm so happy about this. Let me run this one more time. There. All right. Awesome. Yeah, thanks again, guys, and I'll see you next time.